anyone needs them, the accessible slides are available here at tinyurl/mHealthHCI. If you want to tweet at me, feel free. I'll get to it later. And if you'd like to email me afterwards, I'm going to be there tonight, but I won't be here the rest of the week. I have to go to Europe. So feel free to email me if you want to talk about anything additionally. Okay, so we are in an awesome time of innovation. Hopefully that's why you're all here. How many of you use one of the devices that's on this screen? Come on, you all have smartphones. This was a trick question. All right, how many of you use a device that's not a smartphone that's on the screen? All right, a decent number of you. That's actually more than you'll get at a computer science conference, believe it or not. So what we tend to find is that some really awesome people in the health sciences are very interested in using this kind of work, and they're often early adopters of things like smart scales, smart watches, your Fitbit counters, any of those kinds of things. But we need to do some things to help alleviate any challenges that we might have around those kinds of devices by doing a better job with design. How many of you think of yourselves as designers? Okay, a few of you. My goal is that by the end of today, you will all think of yourselves as designers. The likelihood is you already are, and if you're not, you will be. So if we think about what are we actually talking about with design, it's really simple. It's a process. You all do a lot of processes and methods, right? This is part of everyone's daily lives of creating something, so it's a creative endeavor. And this is where I usually lose people. When I say, why are you not a designer? Most of the time people say, well, I'm not that creative. I'm not that artistic. It doesn't matter. You are creative. If you're thinking about a new approach to something, a new process, a new way of doing anything, that is all being creative. So you don't have to be artistic, quote unquote, to be creative. We're going to shape tools. So the output of design is a thing most of the time. Sometimes it's a process, but let's think about tools and things. And they're going to be used by people. So we really have to have people-centered concerns. And Pedro's going to talk a little bit about theory and how that gets incorporated, but for my purposes today, I want you to think about design as always being creating some new artifact to serve some group of people. Okay, what are some basic characteristics of design? Design should be conscious. We're making explicit decisions. It's not a sort of thing that just happens. It should keep human concerns in the center. We've all had things that are badly designed. I would argue for the most part when they're badly designed is because someone decided to be more artistic or more theoretical and not think about the actual people. It's a conversation with materials. So this maybe sounds a little frou-frou to you, but over time, I want you to recognize the way in which we engage with our materials and they tell us things back, and then we do some more things with them. It's not a one-stop thing. It's an ongoing conversation. It is creative. I think I've covered that already. It's about communication. A lot of what design is about telling the idea that you have in your head to someone else, and then maybe an engineer or a product development group takes that idea to something else. But the design part has to be about communication. It has social implications, and it is inherently social. Designers do not sit off on the mountaintop by themselves and come up with brilliant ideas. Not even Steve Jobs did that. Design is a social activity. Okay, so what is designed? Everything. These chairs are designed. These walls are designed, and in fact, apparently they're designed to make me not be that loud, but they're not working. That flag is designed. Everything around you is designed, except for nature, and depending on your religious beliefs, perhaps even that is designed. Anything that is consciously intended for human use, we talk about as being designed, and this is why I say all of you are already designers. How many of you packed a kid's lunch sometime in the last week? You designed something, right? You are designers all the time. But they're often very poorly designed, right? Every time you're getting frustrated with a product, it's not you. It is not the user error, and don't let anyone tell you it is. It is designer error. Okay, so bad design is everywhere. I keep a huge library of these. I bet you Pedja does too. One of the fun things about teaching undergraduate students is the things they send you as examples of bad design. So this is bad graphic design. The headline here is 1 in 4 women will be beaten by husbands, and they happen to have placed an ad right here for Asda that says, treat him this Father's Day, with a bunch of suggestions you might give to this wife-beating husband, apparently. This is bad graphic design, right? This is the ads people not talking to the content people. This is bad graphic design. This is a nicer version of this, but these are automatic faucets that don't turn on if you're wearing black clothing. You may have seen in the news, they also don't turn on if you are black. So we have additional problems with these kinds of things where the sensors weren't tested with the right set of people. Bad design. This is one of my other favorites, right? So for those of you who can't see or don't recognize this, this is 2 urinals, sort of at 90 degrees to one another. It's not clear to me what 2 people are going to use this simultaneously. Probably no one. All right, these are everywhere. If you look for them, one of the fun things I do with my students is I tell them to write down at least 1 bad design every day for an entire quarter, and they never run out of things to report to me. Okay, but bad design is funny, we all laugh, but it also has really big consequences. Does anyone remember the Florida election ballot? Yes. So we have this terrible ballot where it's like, do you vote here? Do you vote here? Where are we poking? It's very confusing because things are pointing inward at each other. Simple solutions point them outward, and we wouldn't have had nearly the problems that we had. Also has human life consequences, right? Not just social consequences. So does anyone know about the Theric 25? Oh, I rarely get an entire room of people who don't know, so this is fantastic. The Theric 25 is one of the great mistakes in software engineering. When people try to tell you that software engineering doesn't have human consequences, they are liars, and the Theric 25 will tell you why. So what happened here is this is a machine that, in this mode, this is electron mode, it has a low current beam, goes across an entire field. When it's in the X-ray mode, it has a high current beam, but it has a target in between. And through a series of errors in the software, you had a bunch of people getting the high current beam with no target. Anyone have a guess what happens in that situation? Yes, radiation poisoning. It's not good. So this is a really simple example where a bunch of problems in the software, as well as in the operator's interface, had created a bunch of mistakes. This is bad design that wound up ending in a whole bunch of people getting really sick. And you can read more about it at that website on the side there. Okay, so but we can try to help. One of the famous examples that we have in the human-computer interaction world is 9X, which most of you probably never heard of, but phone company. And they were going to buy new workstations for all their telephone operators. And they knew that each second that they saved on a call saved $3 million a year, which in today's money is probably, I don't know, 10 million a year, substantial chunk of money. So they did a bunch of user modeling on these new workstations and discovered that actually it was going to slow their operators down over the old workstations. So they didn't implement it. And this is an example of where the sort of science of design can get involved and actually save people a lot of money and a lot of hassle. And we can do those things. This is another good example. You probably can't see this very well given the shape of the room, but this is a medical report. It's giving us a whole bunch of numbers, lipid values, other kinds of things. This is pretty common, what people might get. This is an improvement over the handwritten things that you used to get, I suppose. But it's still awful, right? People can't quickly at a glance see what's going on. So this was redesigned in an electronic system that's very clear, particularly for facing patients, but also even for facing clinicians to show, here's where you are, red, yellow, green. Very easy to know where you should be and where you are and so on. What do your results mean? Quick at a glance, you can kind of see where your problem areas are and so on. This is a simple fix. This is just graphic design. There's nothing sophisticated going on here, and it makes a dramatic difference in what people are experiencing. And many of you, I'm sure, use EHRs all the time and know the pros and cons of those kinds of design choices that people are making. Okay, so by the end of this talk, you're going to be able to be nice to people like me and Pedja, right? All the little nerds and the other engineers that are in the room. Identify some quick methods that you can use to ensure that technologies are both usable and useful. And you are going to be able to create prototypes. You will be designers in the next half hour. Yes? We're ready? All right. Okay, so best practices for the care and feeding of your geeks. Things are really different if you're in computer information sciences. So one of the biggest ones is publishing. Anybody know where computer scientists publish their work? Conferences. We either have some computer scientists in the room, or I think that was Donna. She cheats. She's been doing this for years. So yes, believe it or not, this is where computer scientists put all their work. So when you say we don't look at anything that's not published in a journal, you're missing basically an entire discipline. We have problems. Computer scientists should fix this. We know that. But in the meantime, that's the situation. We work really differently with graduate students. If a graduate student calls me Dr. Hayes, I start looking around for my parents. This is not the way that sort of people work in these disciplines. We work, there's very little hierarchy, and that can confuse and upset graduate students sometimes when they encroach into the medical world and they're suddenly met with a lot of hierarchy. And so they're trying to figure that out. So help them, be kind to them, teach them your ways. Our relationship with theory is quite different. People are a mix of things in computer science and design. Some people are entirely atheoretical. Some people use theory to deconstruct bad design. Some people are creating new social theories, and some people look more like the medical sciences and are building on theory to develop interventions. But the point is, it's really mixed. And so when you talk about theory, sometimes they start going in their head to like proofs and algorithms, and they're not really sure what you're talking about anymore. And you will not find our work in PubMed. This is the biggest challenge I think that we have, right? So there's a bunch of stuff that's getting redone right now in sort of the digital health world because people are only indexing PubMed to look for what has already been done. Yeah?
That's actually changing as we speak.
Yay!
They're beginning to index conferences. IEEE and ACM are giving the jive. So
that's good. I keep hearing rumors that ACM is going to start behaving ourselves better, but I never believe it. So your optimism gives me some optimism. Okay, so, but we are really complementary. This is the good news. And you have a bunch of interdisciplinary teams in this room. And so I think by the end of the week, you'll see some of this complementarity actually play out, right? Computing researchers are really good at finding competent and cheap technical labor. Yay. We're really good at identifying and overcoming a whole host of challenges in terms of usability and technical stuff. One of my favorite things is going into meetings and having MDs tell me, that's possible? No way. And that's really fun for me because that means we're doing something new and innovative and interesting. We're really good at understanding social and cultural context. So we rely much more on social theory for the most part than we do on sort of medical and biomedical theory. And that means that we're really complementary in those kinds of spaces. And we're pretty good at understanding design process, adoption, and usage. Where we start to falter and where the medical sciences and biomedical sciences are really helpful is we don't measure outcomes very well. We get 20 people using our system and saying it was pretty good, and we're like, this is not going to work if we're talking about evidence-based care and actual outcomes. This is what other people do much better. You're really great for the most part at research design, and we often aren't. Right? So thinking really long-term about big kinds of research projects, that's not necessarily our forte. So it's a good time that we can help one another. Okay, so you have some homework. You have the slides online, and you can get these readings. These are things that should be all pretty easily available online. Read them. Thank me for it later. Okay, so now let's move into you guys becoming designers and what you're going to be able to do design and do it well, right? So I've already sort of argued that you're already designers. Now let's be thoughtful and explicit designers instead of sort of accidental ones. Okay, importantly, design is not just lipstick on a pig. You've probably heard that expression before. If you haven't, you have a lovely visual to explain it to you. It is not about making things pretty. Right? It's not about saying, oh, we already built this huge new EHR. Can you now make it like colorful and have nice font? No, that's not going to work. It's about really understanding deeply what architectures need to look like, what social contexts need to be in place and processes need to be in place to make things adopted and so on, not just sort of making it flash on the front end. And you've probably all encountered products in which a bunch of nice, pretty graphics got layered on top of a really crap system. And that's not what we want to learn to do. Okay, so some important key things about interaction design. Firstly, the user is nothing like you. You are all hyper educated. You are all diverse, spend a lot of time with diverse people. You are all middle or upper class. These are things that most people are not, right? So the user is probably nothing like you. The best way to have good ideas is to have lots of ideas. We often get stuck in design. I'm like, oh, that's a pretty cool idea. I'm just going to go do that, right? No, we want to have as many ideas as possible, even things that you think are crap, because they might turn out to be really good later. And finally, enlightened trial and error succeeds over the careful planning of the lone genius. And this is the one I think I have the hardest time working with physical scientists, biomedical scientists, and so on, because it's a little scary to do trial and error. You come from a discipline in which trial and error can wind up in people getting hurt, right? We do a lot of trial and error and thinking carefully about the trial and error as part of the process. Okay, so why do we have a design process? Why is it not a lone genius sitting around being artistic somewhere? I'm not going to go through all of this list, but just so you know, it's the science part of design science, right? That's the point of a process. It helps us to think very carefully and concretely about what we're doing. It prevents us getting blocked. So feeling like, oh, I'm not feeling creative today, therefore I can't possibly make anything. No, we have a process and you go through it systematically, and that allows you to produce. You can stay on schedule and within cost. Designers who don't follow a design process inevitably wind up with scope creep, which is every new feature that comes into your head, you start throwing it onto the system. Makes for a bad system, and it makes for a very expensive system. And it forces you to iterate and keep the user first. And if you take nothing else from what I say today, I hope you will take these two things. Always be thinking about your user, and always be willing to try again, to keep going around that circle. Okay, so what is designed? In the most simple way, we think of the artifact. This little clicker was designed, right? That's anything that we create is going to be designed. A more holistic view, and this is much more what we're starting to talk about in our field, is that an experience is designed. If you're going to stay at the Marriott, the first thing you do is you go to their website, probably, maybe you call someone. If there's a problem, you might call. You usually get an email. Maybe you have the mobile app, or at least you're checking something on the phone. All of these things happen before you set foot in the door at Marriott. Then you set foot inside the door, and now there's kiosks, maybe there's the front desk, there's your room key. All of those things should make a coherent designed experience. And that's the same thing that we're talking about here. So if you're going to create a new system, you want to be thinking about all of the context that's surrounding that system so that the whole experience gets designed and not just a piece of software. All right, this is what people often think of as a design process. So this is our little happy soccer ball. We sketch it, we prototype it, we try it out, and we're done. Yay! Everything's good. No. This is not our process. Our process is way messier. It's cyclical. If you just Google for design process, you'll get 100 different versions of this, where you basically have a cycle of think about a problem, create a bunch of ideas, ideate, brainstorm, make some prototypes, evaluate, and then after you've gone through some amount of iterations round and round this, you might pop out to produce something, actually lay something into production. I'm going to walk you through these really quickly, and Pedge is going to talk to you about an actual example of a project that goes through some iterations like this, but I'm just going to give you the sort of high level. Okay, so when we investigate, we want to think about who the users are, who the stakeholders surrounding those users are, what are their goals, what else has been tried, all your background research. Then we're going to ideate. Lots and lots and lots and lots and lots of ideas. This is the there's no bad idea time period in our cycle. Finally, we're going to prototype, produce something tangible. We're going to talk about what this actually means to prototype. Doesn't necessarily mean make a working system. That usually helps us identify various kinds of challenges, uncover all the nuance that's going on. For me, I'm a very physical kind of designer, so I like to actually get in there and start to feel the different ideas, and then I'll come back to the other cycles. And then evaluate. This is not, we're not generally usually talking about your big outcomes evaluation here. This is about sort of what are the problems, what are the usability challenges, what are the next steps we need to follow, and eventually we'll go into a final product. Okay, so investigate. You cannot design apart from the world in which the actual product is going to be used and the design and the users are going to be. You cannot sit around in the corner and just think of something brilliant. That is a really key thing for you to learn if you hadn't already come up with that. So that's a big no. Instead, what we see is things like this, right? This picture, kills me because talking about Donna being at Nokia, every time I go to Nokia, I'm like, I have a thing where I count fins on phones eating ice cream because this is what happens. They're always eating ice cream, riding their bike, talking on the phone simultaneously. This is not what Nokia probably envisioned when they first created their phone. But that's Finland for you. You probably don't think of the fact that everybody's using a bunch of different phones at once or all these other kinds of things. Okay, so we need to think about who the users are, who the other stakeholders surrounding those users are, what their requirements are, and that's not just sort of functional requirements, but that's all kinds of requirements. The requirement might be I want it to make me feel good when I use it. It could be any kind of requirement. How are they doing this now if they're able to do it now? So what are the workarounds that people are using? How are they sort of stumbling through things? How long does that take? Is it awful? What do they actually want? What do they need? Which is often not the same, right? So this is where clinical guidance often comes in. What else have people tried? And is there possibly another solution? So these are all the kinds of questions you need to ask before you can even start the process of thinking through what possible solutions might be. There's a bunch of different options for this, and this would take us weeks to go through all of these, right? But they're the things that you might think of. So surveys, I actually don't recommend using this as a first option because you usually don't know enough to actually ask survey questions. But focus groups, interviews, think about the competition, what else is out there, what are other people doing? And then contextual inquiry and ethnography. So these are field observation kinds of solutions. Okay. So now we have a better sense of our users. We're going to move on to the ideate stage. So how do we actually brainstorm and think about things? You guys probably brainstorm in your daily lives, at least somewhat. And what we really matters a lot in this for design is the volume matters the most. So, and people have done a lot of research on this. So one of the things, for example, is if you get a group of people in a room, if you all start brainstorming and discussing together, anybody have an idea what happens? You get way less ideas. Yeah, because you start sort of critiquing each other or building on each other's ideas because you get excited about something, and by the end you converge on one idea in your very first brainstorming session. In fact, if you go and everyone sits in their own corner and writes down, just say as many ideas, no matter how outlandish as you possibly can, for say 5, 10, 20 minutes even, and then we're going to put them together. You get a ton more ideas. So those kinds of tricks where your goal is really about volume. And then when you have a high volume of ideas, you can think about them critically and systematically. But without a high volume of ideas, it's really hard to even start to critique these things. You can always come back to a good idea. And I want to really emphasize that with you guys this week because you're all in these groups with people that I think you don't know from before, right? They're all new. So you're probably trying to be nice to each other. So if one person's really excited about an idea, you're going to be like, yeah, let's get on board with that. No. If that idea is that good, you will circle back to it, I promise you. So think about some other ideas first. Okay, the kinds of things we do with ideation. Affinity diagramming. So has anybody ever seen pictures of designers with Post-it notes all over the wall? It's like the canonical designer picture, right? They're doing affinity diagramming. They're basically taking a whole big pile of features or maybe some ideas from users or whatever, and they're putting them on the wall and trying to figure out how they group together. Personas. So this is about sort of, you've got patient Jane, and you've got, epidemiologist Janet, and you've got engineer Donna, right? And we're going to tell you a little bit something about these people that we maybe sort of made up and sort of comes from empirical data. Scenarios, so things like, somebody walked down the street, they wanted to order a coffee, and they pulled out their mobile phone and they ordered it, right? So that's a good scenario for the Starbucks app. Role playing, this can be actually kind of fun, especially with people you don't know. So like, okay, we're going to role play an encounter right now and see what problems come up. The rest of these are actually probably a little bit for the advanced class. And then sketching. I want you guys to all feel like you can sketch. Does anyone ever doodle? Yes? Does anyone think they doodle well? No, no one thinks they doodle well. Maybe a couple of you who probably have an artistic or an engineering background. Engineers actually doodle really well. But you can all sketch, I promise you. You don't necessarily have to share them with other people, but when you see a bad design out there, sketch it down and think about what it might look like to change that. Practicing sketching anytime. You're on an airplane, you're on the bus, you're sitting waiting for a cab, whatever. Practice your sketching. Okay, prototyping. I'm going to talk to you a little bit more about prototyping than I have the last two because you don't believe me that you're going to prototype them. I'm going to tell you that you are. So we're going to spend a little more time on this one. Why do we prototype? It's super hard to evaluate an idea, right? It's really hard to actually critically take apart a concept. You can't play with a concept. You can't experience a concept. It's much easier if you have some kind of prototype. And it's particularly hard for your end user who you're now trying to explain it to, who maybe doesn't have the same clinical or engineering background that you have. And prototyping actually brings a bunch of subtleties to light that you might not have seen, particularly technical constraints. So you start to think about things like screen size or what something might feel like in your hand or on your arm or whatever. Okay, so how do you get started? All you need is a piece of paper. A piece of paper can be a prototype. We're going to keep remembering that. There are three different types of prototypes. I like throwaway ones best. They're most fun. So a throwaway prototype is it only serves to elicit a user reaction. And I have my students do this a lot. So think of the most outlandish, ridiculous solution to your problem that you can imagine that we don't have the technology for 20 years. I don't care if it requires some crazy AI or whatever else. Make it, and make it rapidly so it tests people. It pushes the boundaries of what they're thinking about to some extreme example. And if you have a bunch of extreme examples, you'll start to actually see where the real features are and not what people think about when they tell you abstractly. Incremental prototypes, this is probably the most common, particularly in our research. So we're building these things as separate components and we can put them together possibly, and then we'll be able to make something eventually. But we might throw away a part of it or put in other parts and so on as we go. And then evolutionary. This is what's going to happen more frequently in the private sector and industry as people are trying to roll to a new product. So Fitbit's probably not throwing away their entire device and starting over, but they're taking their bands and they're looking at them and seeing how they can evolve them into something that's a slightly better experience. All right, so low fidelity prototypes. These are the things you can all do. Storyboarding, easy one. I can't doodle to save my life. I'm a terrible artist. But I drew this, and it worked for the purposes of what we were trying to do. So you're just basically making sketches. This particular system was something to help you remember where you were in a cooking process. So let's say you have young kids at home, or you're aging and you're starting to get forgetful. We keep track of the cooking process. You see here, this mom is running because her baby is crying, and she comes back, and she looks up here, oh, okay, I put in 2 of the cups of flour, but not the third. Or whatever. So you're not looking at this bowl trying to remember what the heck you put in there. This particular paper and the reason that we drew this sketch was a study of storyboarding. So if you'd like some best practices on storyboarding that we've empirically tested, you can check that paper. Paper prototypes. There's an entire book on paper prototyping, which is really quite good. So you can check that out. But in the meantime, you can look at some examples. So I said you don't have to be good at drawing. Pretty clear this is not a very pretty picture, right? But you get the point of the picture. So what we see on this picture is some tabs, and you've got some dialog boxes and a little preview portrait and some radio buttons and some buttons that you might push. And that's enough for a user to understand. And bonus, because it's so ugly, they're more likely to give you honest feedback. If you show them this exact same thing but looks pretty and looks like something that might actually be an interface, most of the time they're going to say, yeah, okay, that's okay. But if you show them this, it says, I'm not anywhere near done with this. We haven't written a line of code. What do you think? And they're going to rip it apart. And that's what you want. So how do you get started? Get some poster boards. That can be your background for your different interfaces. Blank pieces of paper, large pieces, small pieces, index cards, all of these different things can represent different parts of your interface. So I always tell people, go to Staples or wherever, get like Post-its in every size and shape you can imagine, because they're really easy to pull on and off of your interface as your interface updates, and they're really cheap, and they come in different sizes. Scissors, highlighters, removable tape, anything that you might want to be able to add to your interface. And just have fun with it, and think about, okay, what does it actually look like to use my Mac, but not, and now it's on paper. So here's what backgrounds might look like. Poster boards, the way a lot of people do this, so you get a really big thing and then you can stick the pages on and off as you're explaining what would happen as you walk through the interface. Manila folders are also really popular, more popular when people were using a lot of tabbed interfaces, because Manila folders make really handy tabbed interfaces for you really easily. You can print things out, right? So you want to be careful with this because you only want to print things out that really are pretty stuck. As I said, people are much less likely to give you feedback on the things that look like this. But if you wanted to say redesign a web browser, you could print out a bunch of web pages and say this is what it looks like on the inside. Now let's talk about your menuing and your other structures that are on the outside. You can also incorporate physical devices. So this is from Carol Snyder's paper prototyping book, which is why it's a Palm 5 from like 12 years ago. So forgive that, but you get the same idea, right? So you can be like, okay, here's your desktop view of your calendar, and now I'm going to stick a Post-it on my, iPhone, and let's talk about what it's going to look like on the iPhone version. And you can go back and forth between these different devices. Or I sometimes will just pull out a deck of cards because it's about the size of a smartphone and say, pretend this is your smartphone. And those kinds of tools, whatever everyday objects you have, work just fine. For scrolling, really easy, right? You just draw your little scroll bars, and you can set them up to put a piece of paper. Or if you're really creative, I've had students cut out the inside and actually physically sit there and scroll the interface up and down for people. That works. You can draw in radio buttons. Some people also, what you can't see very well here is these are little stick-ons. So you can have people actually stick, because you want them to walk through the interface as though it was a real interface. And so if they've got little things and they can physically interact, then that works pretty well. Tab dialog, we already talked about that a little bit. Okay, limitations of paper. It basically looks like a touch screen. So if you really want to understand keyboard shortcuts, using the mouse, things like that, you're not going to get a very good version of that. The graphics are only as good as you're going to draw, right? So you don't get a great idea of any video content or zooming, anything like that. There's all kinds of unexpected issues. Refresh time, which is the amount of time between when the user does something and when they get the result back, is pretty slow for paper prototypes. So they might get frustrated with that because they're waiting for you to scramble across the room and grab your other Post-it deck. Okay, medium fidelity. These are things like Wizard of Oz is one of my favorites. So you don't have to have a super smart artificial intelligence engine on the back end. Just put a person in the other room and have them pretend, right? So this is an example from the early 80s when speech recognition was brand new and you couldn't do it very well. So what did they do? They had people talk and then listen and then talk back. And from the person's point of view, they thought it was the computer, and it allows you to test a bunch of things as though the technology worked. And the same is true for intelligent systems today. All kinds of stuff to apologize to Peter because I think he's this morning talked about doing this better. But when that's not quite working, you can do Wizard of Oz type thing. Interface building, wireframe software. So you can prototype all kinds of things just in PowerPoint. Right? It's a really easy thing, and let people actually click through and play with your interface. You can also use things like OmniGraph, and then Kaku is free at least for the first 30 days. So that's a pretty easy little interface building piece. And this allows you to sort of have the basic sort of stick figure version of your interface. So it looks a little more sophisticated than your paper drawings, but it's still not a full-fledged system. Okay, so once we've created, you'll notice, by the way, I skipped high fidelity prototypes. Most of you will never need to make a high fidelity prototype. That's what you have partners in computer science and engineering and other places for. But your early stage designs, you can do the low and medium fidelity stuff without all those fancy geek people, right? And that's fine, and come to them with more ideas. Okay, so evaluation. This is not the same thing that we're talking about when we talk about sort of biomedical type evaluation, right? This is evaluation of the interface first. Does it work? Does it work the way we expect it to? Automated procedures. This is a new, very active research area to try to find some bugs. They can find some of these things, particularly on the software side, but it's really hard. Ultimately, you can't know what to iterate on and how to fix things unless you actually test it with people. And we're trying to answer, did we build the right thing and did we build it right, before we try to answer the did it work question, which is much more in the biomedical domain. So the kinds of evaluation methods that we might use. There's a bunch of them listed here, and I'm not going to work through them with you, but the Nielsen Norman Group has some really nice articles online already about what's called discount evaluation. So how do we do quick evaluations that don't cost very much and don't require a full-fledged experiment and someone coming in just to find usability problems? Most importantly, evaluation drives your iteration. So you may recall in the circular diagram, it's not a perfect circle. Sometimes we go back to different steps. We go all over the place in that. And that's because sometimes if we find that there's problems in user performance, we're not doing very well with it, we probably need to return to prototyping. But other times we find that the problem is whatever we built just doesn't match the conceptual model that the people that we wanted to build it for had. And that means we probably didn't really understand the problem very well, and we need to go back and ideate. So iterating on your prototype at that point is not going to help you. You got to throw that prototype away and start over. And sometimes if we find that it's just not appropriate in the particular context that we thought it might be used in, or people want to use it in a different context and it's not appropriate there, well, then we might have to go back and investigate that other context more. So be thinking always about where do the problems actually point you to, and not just trying to fix the prototype. All right, so how do we actually produce things afterwards? If we get to the point where we feel pretty good about our product, or about our prototypes and so on, then we can go from a functional prototype to some kind of final product. And that requires a whole bunch of people, right? So that requires engineers, but it also might require people who do packaging, if you've got a piece of hardware, right? It might require help systems, manual. That's something I can tell you the people in my world do not do very well. So, you know, it might require training, marketing, branding, distribution, all of these kinds of things, right? So this is where we start to really have to think about a lot of different disciplines coming together. All right, so I walked you through sort of my version of a design process. I'm going to tell you there's some serious experts in HCI in this room, and they probably don't agree with me, because there is no agreement on an exact design process. It's not like everyone's sitting around being like, well, if you follow steps 1 through 4, you're good to go. So do what works for you, but try to do it systematically and thoughtfully. And just remember, design is iterative. You have to keep people central in here. It starts and ends with understanding the user. They're never perfect. And it's a skill and somewhat of an art to know sort of when to stop. And with that, I'm going to stop and give you these additional resources.